Alright, more derivatives. So we've got part G here, and we got this function, and we have to do the same thing as always. We have to write it differently. Exponential of natural log of x plus y to the z. And so we are going to bring down the z, and then the only other thing we need to do is write things using projections. So pi 3 times natural log of pi 1 plus pi 2. Okay, so now we take the derivative, evaluate it at a, b, c. And again, the first part, as usual, is just going to be, because you have exponentiation on the outside, the first part's just going to be a plus b to the c. And we're going to end up multiplying by pi 3 times natural log pi 1 pi 2, pi 1 plus pi 2, prime. And so we have to do the product rule. So we get pi 3 prime times natural log pi 1 plus pi 2 plus pi 3 times the derivative of natural log of pi 1 plus pi 2. Alright, so what's going to happen here is here we're going to get 0, 0, 1. And now here we can go ahead and replace this with the natural log of a plus b. And now we have c times, now when we take the derivative of this thing we have to use the chain rule, so we're going to get 1 over pi 1 plus pi 2 times the derivative of pi 1 plus pi 2. Alright, so we got a plus b, power c. Now here we've got 0, 0 natural log a plus b. And here we've got c over a plus b. And when we take the derivative of pi 1 plus pi 2, we get 1 comma 1 comma 0. Okay, so that's what we have there. So we have a plus b to the c. And we've got 0, 0, natural log a plus b. And then we've got c over a plus b, c over a plus b, 0. And then finally you just combine everything together. So we're going to get c over a plus b, c over a plus b, and natural log of a plus b. Alright, and there we go. So that's G, and now we're going to move on to H. Here we've got f of xy is sine of x times y, which again is sine of pi 1 times pi 2. So now we can just go ahead and take the derivative. So chain rule, we have sine prime times pi 1 times pi 2 times the derivative of the inside. And so, of course, the derivative of sine is cosine, and we can go ahead and replace the inside with AB. And now we have to use the chain rule, so we get pi 1 prime times pi 2 plus pi 1 times pi 2 prime. And so we have cosine AB times, now pi 1 prime is 1 comma 0, because again this is a function of two variables. And then pi 2 is going to give us B plus a times pi 2 prime is 0 comma 1. So what we end up with is cosine of AB times, and then we'll have B in the first coordinate and A in the second coordinate. And there we go. That's all there is to that. Okay, so now what we're going to do is we're going to move on to part I. So first what we're going to do is we're going to let g of xy be sine of xy, and so we know that dg is going to be cosine of ab times b comma a, because that's exactly what we did above. Okay, so now f of xy in this problem is going to be sine of x times y to the power of cosine of 3. So remember, cosine of 3, that's just a number. But anyway, so this is going to be g of x comma y raised to the power of cosine of 3. And then, of course, we want to write this, because this is something being raised to a power, we want to write it using exponentials. So this is the exponential of the natural log of g of xy to the cosine of 3. And so it's the exponential of cosine of 3 times the natural log of g of xy. And excuse me. Remember how I said that when we want to get these functions into a form where like the only thing we have to plug in is the vector? Here, this is g of x comma y. And so we're actually plugging in the vector x comma y here. And so this is indeed the form that we want. And so what we can do is we can go ahead and evaluate the derivative of f. Of course, on the outside, because we've got an exponential function, when we take the derivative of the exponential, nothing changes. So we're going to keep this here. And then we have to multiply by the derivative of the stuff on the inside. So derivative of cosine 3 times natural log of g x y. Okay, now the stuff on the outside, basically what's going to happen is we're going to work backwards and cosine 3 is going to go back up. We're going to end back up with sine of AB to the power of cosine of 3. And now for this part, for the other thing that we need to take the derivative of, the cosine 3, that's just a scalar, so that will come out. Then we take the derivative of natural log of g. So using the chain rule, that's 1 over g of xy times the derivative. So I'll just write this as dg of xy. And of course this is dg of xy evaluated at the point AB. So yeah, so what this is going to end up being is we have sine of AB to the power of cosine 3 times cosine 3 times, and now here we have to take 1 over g, so this is going to be 1 over sine of AB, because we're evaluating again at a comma b. So let's see here. So of course the x and the y here that I'm using, these are just dummy variables. You can sort of like just ignore them, because the only reason I'm including them is so that we know what function we're talking about. In fact, I should actually just get rid of these. So this is going to be 1 over g times dg, and 1 over g, that's 1 over sine AB, because we're evaluating at AB. And so dg is going to be cosine of AB times b comma a. And so we end up with what? So we've got the cosine of 3. Now, sine of AB being raised to the power of cosine of 3, but we're also dividing by sine of AB, which is, remember, 1 over sine of AB is the same thing as sine of AB to the power of negative 1, and so we can actually put that minus 1 up here. So this is cosine of 3 minus 1. And then we have cosine of AB, and we multiply that entire scalar times the vector b comma a, and that gives us our final answer. Okay, and now the last one is part J, which is actually really easy. So f of x, y, z is equal to, so let's see here, we've got sine of xy, sine of x sine y, and x to the y. What we're going to do is we're going to combine parts h, c, and a, respectively. And so what we're going to end up with is when we take the derivative of f, this is going to be a vector, which is going to have 3 rows. The first row is going to be the derivative of sine of xy. Second row is going to be the derivative of sine of x sine y. The third row is going to be the derivative of x to the y. And of course, when we take these derivatives, we have to express them in such a way that the dimensions work out with the number of columns of this resulting vector. Okay, so let's see here. This is not a function of x, y, and z. This is just a function of x and y. So what we should end up with is each row should have 2 entries, so there should be 2 columns in this matrix, and we just use the previous parts to figure out what these things should be. Of course, this matrix is being evaluated at the point AB, so what we end up with is, okay, so the derivative of x times y, if you multiply everything out, you'll have b times cosine AB here, and a times cosine AB here. It should be enough room. Okay, for the sine of x sine y, we'll have cosine of a sine b times sine b, and then the other column is going to be cosine of a sine b times a times cosine b. Then finally, the last one we're just going to have b over a times a to the power of b, and we have a to the b times natural log of a. Because we're just basically combining the results from previous parts of this exercise. And there we go. That's how we figure out the derivative of f, and that finishes up all the parts of this exercise. So again, this exercise, we have to use sort of a strange set of tools that you might not be used to working with. I certainly was not used to working with these tools at first, and I was like, why would we ever want to do things this way when we can just do things using the partial derivative matrix that you'll learn about in either the next section or the section thereafter. And I do prefer building matrices that way, but it's good to know that you can do things like this, and it's good for your own mental capabilities to be able to do problems in different ways and be able to think about them differently. But yeah, that's about it for this exercise. We are now done.